is easy, but writing them well is hard, right? Because with the dynamics of OSGi and the timing of when bundles are started relative to your bundle, it's hard to keep track of these things. And it'd be much easier if somebody else figured it out once and you got to reuse it. So we added it in release 4 in 2005, and in the next version of the spec, we added some minor enhancements, nothing really major in 1.1, but a big change came in 1.2 when we added annotation support. That made it much easier for the program. The most recent update was 1.3. We added a bunch of new features, field injection, component property types, and also the ability to introspect. So we have a runtime service. You can figure out through DTOs, why is my component not working? And an interesting thing is Open Liberty. Who's heard of Open Liberty? So Open Liberty is IBM's WebSphere Liberty product, open sourced. So we announced that just before Java 1, so we talked about that quite a bit at Java 1. Open Liberty is based upon OSGi. It is a huge, massive OSGi project. There's like over 900 projects in the GitHub repo. And if you grep through the source code, which I did a git grep on @component, and I found over 590 Declarative Services components in that source space. So they're a huge user of Declarative Services. So basically, Declarative Services is an XML-driven runtime, right? It's to be performant on smaller systems and lazy, avoid loading classes we don't need to load. XML is the driver of Declarative Services, right? So when DS processes your bundle, he doesn't go crawling through your class files looking for annotations. He goes looking for XML, right? So I can load an XML out of a bundle. I don't need to even have a class loader to do that. And so the XML has all the information that Declarative Services needs to operate your bundle. And so if your Declarative Services is a component that offers a service and nobody uses your service, we never even have to load your class. Declarative Service will register a service on your behalf in case somebody ever needs you. But then again, who really wants to write XML, right? XML writing is for computers. Nobody wants to write XML. And so annotations comes along. And so we have a set of annotations, and we have tools like B&D that basically do the work of turning the annotations in your program into the XML that the runtime cares about. So that's an important thing to know about DS, is that there is this difference between the annotations in your code and the XML read by the runtime, and that you do need a tool to process it. So as we add features to Declarative Services, we have to add support in the tools. And so some of these new features that I'm going to talk about today in 1.4 are not yet final in the spec, right? Because we haven't released the spec yet for DS1.4. So these are coming features, and we haven't put all the support in the tools. Some is in there, but not all of it. So this is the future. So we basically have 3 main sort of annotations one might use as a Declarative Services programmer. We have one that declares we're a component, @component. And so you basically would annotate your class with this. You often want to be constructed, right, and set up with some objects. So we have an activate annotation, and we'll pass you some initialized objects. So it might include some configuration information. It might include context that you can access either the bundle or the component context and let you get access to the system. And then generally what you want to do is use other services, right? You want to use other services in the system. So that's what the @reference annotation. It says this is an injection point. I want to reference another service. So since you're all experienced Declarative Services programmers, and you probably used the Declarative Services 1.3, you've got anyone who's used field injection? Oh, you really should use field injection. It's very good. We're going to talk a bit about what's new now in 1.4. But if there's any questions about some of the other stuff, we can talk about that too. So the first new thing, which probably the big new thing, so the headline feature, if you will, for 1.4, is Constructor Injection. So, from the very beginning, DS 1.0, we had method injection, right? The most sort of obvious form. So people would write @reference, they would have a set method, and we would inject their service reference into their component by calling the set method. And we had companions for that too, because Declarative Services can come and they can go. we had unbind methods too, so we could tell you that your service went away. But at some level, people said, this is a lot of boilerplate. I don't want to be writing these set methods and these unbind methods and dealing with the code that I have to do. I just want this stuff in a field. Can you just inject a field? And so in 1.3, we had field injection. Now you can @reference a field. And so you can just have the service stuffed into a field magically for you by Declarative Services. And we support dynamism. If your field is volatile, we can alter it as services come and go. We support collections. So we can manage all that for you through fields. But there's also a class of people that wasn't even enough for them. They needed constructor injection. And a lot of times that's because of two main reasons. One is they want to use final fields. And the only way you can use final fields is to set them in your constructor. And so that's a key use. Another example is people have existing types they want to use. And if they can't get the values in the constructor, they can't use those existing types. And so we now add constructor injection. So one of the key things, of course, with constructor injection, since you only construct your instance once, is you can only use static references, right? If you need a dynamic reference, right, a service that can come or go, well, then you have to get it through either field or method injection. But if for static only references, constructor injection is fine. So what we now allow is that you can have your constructor can be marked with the @activate annotation, and that says this is my construction point. And then of the parameters for your constructor, a set of them can be marked @reference, which means these are services that you want injected in this constructor parameter. And then you can also have other parameters that hold the activation objects. Much like the field injection support that we have, the support for constructor injection basically takes all the same types. So anything you can inject in a field, you can inject in a constructor parameter, except for, of course, the dynamic support. So if you want to get a collection of services, you can get a list of services injected in your constructor. And like the field injection, we'll dig the service type out of the generic reference of the parameter. And again, like in the field injection, sometimes you don't just want the service object, you want information about the service object, right? So you might want the service reference. You might want to be able to access it in a service prototype manner. You might need the component service object. Sometimes people want the service properties of a service, so we can inject them in the form of a map. Or you can even get the tuple version, which is one object that holds both the service object and the properties about the service. So basically all the forms of injection you can get with field injection, you can get through constructor injection as well. And the other thing you can do, so of the constructor parameters, right, you can decorate a set of them with @reference, which means that they're your services that you want injected. You can also get the activation objects injected the same way, right? So through the activate method that you had before, you could receive your component properties, you could receive a component context or a bundle context. All those sort of things you can also request to be injected into your constructor as well. And so basically any parameter of the constructor that's not decorated with @reference must be a component, an activation object type. So you can get them all injected through there. And this includes the component property types in the example here of the props. And so because we add support in the constructor to get the activation objects injected through the constructor, for completeness now, we also let you get your activation objects injected in fields. And so it's just another slight addition. You can now annotate the field types, the fields that hold your constructor, your activation objects. So if you want your component context injected in the field, we can do that now for you too. So basically, at this point, you don't necessarily even need an activate method anymore, right? You can get everything you need either through your constructor or through the field injection of these activation objects. So that sort of gets rid of even more boilerplate. But we do still support the activate method because it is sometimes key for as sort of a post-construct activity. Sometimes you might get a set of arguments through your constructor. You might get a set of them through fields, or even, depending upon your needs, through some setter methods. But you sometimes also need to know, when is it over? When are all the things available? Because I need to do some initialization, some setup. And you can still use your activate method as sort of a post-construct time. So when you're called at the activate method, you know that everything is done, all of the objects have been stuffed, you're constructed and ready to go, and you can do whatever post-construction methods you need, or activities you need. So the next big addition and support for 1.4 is more enhancements to component property types. So who here has used a component property type? Oh, okay. This is another cool feature of DS you should definitely begin to take advantage of. So component property types basically let you use your component properties in a type-safe manner, right? So Declarative Services has always supported the ability for components to have properties, but normally the way you get them is through a map. So you have this map of string onto object, and so you have to do all the digging around through the map and have to know a priori that the value of this property is an integer or a string and handle all that stuff. So that's not really type safe or convenient. That code's not fun to write and can be error prone. So what we did in Declarative Services 1.3, and we're enhancing even further here at 1.4, is the support for these component properties types. So basically, a component property type is an annotation, right? So annotations, as we all know, are basically just a limited form of a Java interface. So they have limitations on the methods because they can't have arguments, and the types that the methods return. But so they actually work very well in terms of a way to map component properties into an object, because they map well to the type supported by configuration admin, which is where we get our configuration from. So an example here, we declare an annotation called props. It has a member on it, my_port, and it has a default value. So that's sort of very interesting too. I can now declare my default for my configuration properties in a type-safe way in a Java interface. And we have some name mapping rules. So we map the name of the annotation element onto a property name. So underscores become dots, since dots are very popular in property names. And so this is all spelled out in the spec. And then in your code, you can have an object of the props type injected into your component. So that means if you need to know what the port is, you simply just call a method on that object and you get the port back in a type-safe manner. So even if it was a string in the configuration admin database, you can have it given to you in the form of an int. So from your point of view as a programmer, it's very nice. You have a type-safe way to declare the properties that you have, the values they have, and the way you can use those values. And so this is all stuff from 1.3, except for the constructor injection in the example. But otherwise, it's as exists today. So the problem we had, though, is that's all cool, that's all nice, that's all type-safe. I get lots of good value out of that. But what if I don't want to use 8080 on my component? Right, because maybe this props interface is a shared annotation. Many different parts of my project use it because they all need to know a port in their configuration. But maybe my component has different needs. I need to use port 9080 because I'm different. How do I specify my default is not 8080? Because the annotation is shared by many components. So then I have to fall back to use the property element of the component annotation to tell a different value. And then I'm back to programming with strings. And of course, we lose all of the awesomeness of type-safe programming with annotations because we're now messing around with strings, right? I could forget to put :integer on it, so it's not an integer anymore. Or I could otherwise mess it up. Maybe I'd forget that the my_port really maps to the property name my.port. So there's plenty of opportunities for me to make an error, and who wants that? So what we do in 1.4, we're introducing a new meta-annotation called component property type. And so if you meta-annotate your component properties with that, you can now also use component properties as a way to set the properties of your component. So this replaces what was on the previous slide. So instead of having to use the property element of component and a string, I can now just annotate my component with props. And I'm going to guarantee to get the right name of the property and the right type of the value, because the compiler will complain if I get it wrong. And it's always, that's always nice. So this is a nice productivity improvement for developers. Yes, sir, in the back?
I use multiple of those annotations on one component.
Well, it's up to you how you define props, right? Because you're the definer of props. If you make it repeatable, you can, for sure.
Okay, so if you enter the repeatable annotation. Well, if there's a second one called props2 or extended props.
Sure. Yeah, I mean, at the Java compiler level, they're just annotations. So what the tool has to do, what B&D has to do, is when he's processing this class and he sees its annotated at component, he has to then look at all of the other annotations on the class, see if they're meta-annotated with component property type, and then treat them as if they're a component property, right? So he would introspect their elements and the values you set when you use them. And then from that, Declarative Services, or B&D, will build up the XML properties. You're limited to the types supported by an annotation, right? So you are basically, it's the primitives, string, class, enum, right? I think we support everything except another annotation because that doesn't mean anything. Pardon? An arrays of all those. Yeah, basically everything that is supported in an annotation is supported by the configuration admin configuration dictionary, right? So it's a nice, fairly isomorphic mapping. Well, see, right. See, in 1.3, we use props to read the configuration information, not to set the configuration information, right? So basically, this is me saying, this is what I want it to look like when I read it, but if I want to set it, I have to do this. So in the previous chart, it's given to me to read my configuration, right? So the big change now is that we can actually also now use it to set the configuration, right? So it's both an input now, an output and an input. So we're writing our property here, and then in the code, which I lied it out, it would be the same as before. I can get a props object injected, and then I can call my port on it to get the value, which might not be 9080 because somebody could have gone into my system and configured it to be, 243. Well, if you want it in some custom type, yeah, you would have to do the converter, right? So, that's the same as true because configuration admin only holds simple types as well, like a string. So you want it converted into some fancy type, you would have to have a way to do that. Okay, and so the other addition, since we're supporting using annotations as a way to set properties on your component, right? We want to make it as convenient for you, the developer, as possible, right? So we also have special support for what are called single element annotations. Who knows what that is? Right. Okay. It's two guys in the back. So basically, you've probably seen these before and never knew what they're called. But a single element annotation is an annotation that basically has one element named value. It can have other elements, but all of those have to have default. And the nice thing about single element annotations is you can write nice things like this. You don't even have to say the element name because the value is what is assumed to be. So it gives you a very nice and concise way to use an annotation, right? You don't have to say, my port equals. And so what we do in single element annotations is instead of using the name value for the property, which would sort of get redundant if everyone did that, we derive the name of the property from the name of the single element annotations. So we have some slightly different mapping rules where we lowercase all the letters and we insert a period between the lower to upper junction. And so you end up with the same myPort property again. And so you can define a set of these nice, convenient, and easy to use annotations, and they also get mapped nicely into your properties of your component. So this makes it much nicer from a programmer's point of view to set properties on his thing. You can create a nice menu of these annotations, and the component developers can just annotate up their components, setting property to value this, value that. Very nice. But of course, sometimes properties have long names, right? It's not just, my.port. We often use groupings, right? We have standard prefixes on properties. OSGi does this, right? We often have a lot of properties that start with OSGi dot because we want to differentiate ourselves and make sure we don't collide with other people's. So if you work for the Acme Corporation, you probably have a whole bunch of properties that are all starting with Acme dot. But the last thing you really want to do is have to name all of your interfaces com, acme, something or other. Right? It gets sort of a waste of space and doesn't look very nice in your code. So the last thing we put in support here is for the special constant. So if you put the prefix underscore constant in your annotation, we'll automatically add that to the front of the derived property name. So an example here, we have server port. Because it's a single element annotation, that becomes server.port, and then we prefix it with the value of prefix. So you have the nice long property name you would probably use. So that's another way to make it nicer for the programmer, but still have access to the full property names that we might use. Right, so the mapping rules for single element annotations is you take the type name, you lowercase all the letters, and you insert a period between the transition from a lower to an upper. So that becomes server.port. And then you put com.acme dot in front of that, and then you have the full property name. And since these are so awesome, we've actually are going to define a whole bunch of predefined component property types in R7. So this is very interesting for people that use the HTTP whiteboard. Because right now, if you want to use HTTP whiteboard with declarative services, you have to write this sort of hideous component annotation, because it's got to say property equals some very long name equals some value, right? And so there's a million ways for you to misspell the name and get the type wrong on the value, right? So now we're going to have a bunch of predefined component property types from some common things like service ranking, service description. Most all of the HTTP whiteboard service properties are going to have annotations defined for them. And the same is true for the forthcoming JAX-RS specification. So if you need to annotate, when you annotate your component with JAX-RS name, that will generate a property, OSGi.jaxrs.name. And so you get to use a nice annotation, and the runtime gets the property name it needs on your service. So it makes programming a lot nicer than it used to be. Component factories. Who here has ever used a component factory? Actually surprised. Okay, so we got a small enhancement to component factory coming. The problem we had with component factories before is that they're very lightly decorated. So if you did a component factory, the component factory service basically had only two properties on it. It was the name of the component and whatever the value was of the factory property, right? So you had two things on it. So that's fine if you only had one factory, right? There's only one widget factory. You can easily find the widget factory and use him. That's fine. But what happens when there's multiple widget factories and you're trying to figure out which widget factory is the one you want? And so what we've done is we've added support for factory properties in addition to service properties. So they're sort of separate. So when the factory properties are used when DS registers the component factory, versus the properties are used when he registers the services the factory creates. So it's a bit, so basically this lets you do some interesting things. So now I can have multiple widget factories that have some other properties that I decorate them with, right? I can specify the qualities of the widgets that they make, right? And or the cost to make a widget, or some other interesting way that you want to decorate the factory. And then if you're interested in the factory, you can go ask for one, and you have more power now, right? You can reference the specific factory or some subset of factories that meet the decoration quality. So it just gives us a bit more power to use factories and differentiate between them. Logger support. So I don't know if anyone was here last night. We had an OSGi BOF last night, and Ray was extolling us on the virtues of the changes to the logger service. Woo! So yeah, we're not going to talk too much about it, but we have a fairly big enhancement to logging support, right? Log service was a release 1 service from OSGi back in 2000, and it pretty much hasn't changed in the last 17 years. But we're adding SLF for J-like support to the log service now. So you'll be able to get a logger factory, and the logger factory can create loggers, and each logger can be individually configured to its log level, so much, like all the power of SLF for J logging, but with all of the control that OSGi has, right? We can configure it through config admin and all that sort of stuff. But if you want to use a logger, right, normally what you do today in SLF for J is you have some static thing that calls the logger factory, get logger, and pass in your class object, and he makes you a logger. And that's a fine way to do it for SLF or J, but if we're going to do it in the OSGi way, it's based on services. And so a public static doesn't help us, right? There's no static method to call to get this thing. So we need to get the logger factory service to create the logger for a component. And who wants to write that boilerplate? I don't. So we want to make it easy for you to do that. So we have special support in Declarative Services for this new logger stuff. So basically, using field injection, which is probably the most obvious way you'd want to do it, you declare a field of type logger, which is what you're going to want to log with. And then if you annotate it with that reference service logger factory, then Declarative Services will do the get logger call for you as a service. Right? So he'll look up the logger factory service based upon the at reference. And when he sees that the field to receive the service is not itself of type logger factory, but is of type logger, he'll make the call internally to get a logger object for you and then for your implementation class and inject it into the logger field. So basically, logging with OSGi and the new support is basically an at reference on a field, and then everything else just looks like SLF for J. It's logger.info, logger.debug. So it's very straightforward and easy to get sort of the power of SLF for J style logging in an OSGi way with Declarative Services. So it's just a nice little extra from Declarative Services to help you use the new logger support. Yeah?
If we use a service factory or component factory, does that mean every service or component instance creates its own logger instance?
Well, what's going to happen then is that the Declarative Services is going to call logger factory get logger for your implementation class. But of course, it's the same logger object. Just so every instance has a copy of that logger object.
Okay, yeah, because the static thing with SLF4J is to reduce the number of created logger instances in your runtime.
Right. So again, but there's only one logger instance. It's just injected into multiple instances.
Okay, perfect.
Yeah. Okay, so that's the new logger support, and of course there's a bunch of other minor tweaks here and there in Declarative Services, but by and large, these I think are the headline items that are going to be in DS14. So I definitely highly encourage you to take advantage of certainly the component property types. It'll make programming much, much happier for you. So I hope that was informative, and thank you very much. Any questions? No? Oh, yes. With service? Right, so basically, since it's using the at-reference annotation, you can use it the same way you would on a field or on a method, right? You can decorate it up with your target expression, all that sort of stuff still applies. So all of the rules about using a reference and how the reference selects a service are the same regardless of whether you're using it on a constructor parameter, on a field, or on a setter method. Mm-hmm. I'm sorry? Right, you have to do that anyway, right? I mean, right. So I mean, you can't. You always have to use the. Right. So you see in the example here. Right. So you always have to use the at-reference annotation, right, to tell DS that this component, this parameter is this reference. Right, so, and if you want to do here, you could, because it's an annotation, you can put parens and fill out other parts, right? You might want to say, I want it to be this target, or I want, some other, right? For example, if you're using a reference on a list because you want multiple cardinality, you could put properties in here like, I want the minimum cardinality to be 3. Don't even bother me until you've got 3 example services. Right, so it's the same expressions that you might use in other places, you just have to use it. So it does make your constructor look long, but that's the fun of annotations. Yes. Neil? Oh, go ahead.
You mentioned that the field injection can also run on connections.
Yes.
Is there any recommendation regarding the threading issues? Should you use a synchronous step or something?
No, you don't have to worry about that at all. So so basically, like this list example here, this could be a field, right? And if you annotate it with that reference, Declarative Service, or BND, when he analyzes your code and turns into the XML, he will look at your field. And so if your field was private list example, he would say, okay, it's not volatile, so it must be a static reference. Right, so he basically, Declarative Services will create a collection of a list, and he will inject it into your component, and that's it. He'll never change the field again. Right, but if you put volatile on it, then he would inject a collection, and every time it changed, he would inject a new collection. Right, so as long as you keep going back to the field and getting it, it works fine, because the field is marked volatile, you'll always get the latest collection that's there. So the key answer there is always go back to the field, never keep a copy somewhere else, because Declarative Service doesn't know you have that copy. Neil?
So links to my earlier question would be the property types. One thing that I wanted to do in the past was reuse the same property type across multiple components.
Mm-hmm.
But of course, Java doesn't allow you to inherit these annotations. So it is difficult to have something that's almost the same as another configuration with extra fields. So does that mean I can use two different property types, not just on the writer, as you say, writer configuration, but also on the consumer? I'm not sure if that's possible in 1.3. So if I want to, I get a single map from config app,
Right.
but I want to break it up into multiple configuration property types.
Yes, you can use them. Yeah, you can have multiple, because basically it will, the object that's created, right, that represents that component property type is backed by the complete configuration dictionary. So you can have multiple objects backed by it. So some will see some properties, some will see different properties, depending on how you've organized your set of component property types. Right, so you can imagine that you could, certainly in the HTTP whiteboard example, you might declare a component, which is your your servlet, and it might be decorated with multiple of these predefined component property types. The filter and the pattern and the name and other things, so you can use multiple of them.
Can I do that in my activate method on 1.3, or
To use them to decorate your component requires 1.4. Right, you can use them in your activate method as inputs, multiple, yes, today, that's 1.3. Mm-hmm.
No? I just want to point out that after the